Okay, in our last section we talked about multiplying monomials. Now we're going to go over how to divide monomials. When we divide, we are going to subtract their exponents. So just like our inverse circle, I'm going to draw in the corner here, the inverse of multiplying is dividing. So if we switch to division, when we multiply, we added the exponents. Now when we divide, we are going to subtract. The second thing I want you to remember is that a value raised to the 0 power is always going to be equal to 1. So no matter if I have x to the 0, if I have 5 to the 0, if I have 26 to the 0, if I have z to the 0, all of these are going to equal 1. Anything to the 0 power is 1. Okay, so now we are going to simplify each expression. Starting with the first one, we have like bases, both are m, so that means we can simplify, and we are going to subtract their exponents this time. So my base is going to be m. I'm going to start with the exponent on top, 7 minus 2. 7 minus 2 gives me 5, so my final answer is m to the 5th. We always want to do the exponent on top minus the exponent on bottom. So if we look at number 2, we're going to start with our x's. Our x's have like bases, so I can combine those. I have x to the 9th minus 4. Then same with the y's, I can combine those. Y to the 5th minus, and remember if there's nothing there, that's a y to the 1st, so I subtract 1. So my final answer here, 9 minus 4 gives me 5, and then 5 minus 1 gives me 4. Okay, for number 3, I can simplify my numbers out front, my constants. 24 divided by 12 gives me 2. And then I can simplify my bases. So I have z to the 8th and z to the 3rd. So that's going to give me 8 minus 3. So my final answer here is going to be 2 times z. 8 minus 3 is 5. Okay, number 4. Again, I'm going to start with those coefficients out front. I have 30 over 42. You can put that into your calculator and simplify it that way. Or, if you know in your head both those numbers, we can simplify to negative 5 over 7. Then I can look at my like bases. I have a, 3, and a 1, so 3 minus 1. Then for my b, I have 2 minus 2. And then my c, I start with 9 minus 4. Now I'm ready to simplify. I got 5/7. 3 minus 1 is 2. 2 minus 2 is 0, so b to the 0 is just 1. And then c, 9 minus 4 is 5. So this is my simplified answer. Okay, number 5. 10 over 10, I know that gives me 1. And then if I have h to the 4th minus 4, that's going to give me 1 times h to the 0, which is just 1 times 1, which means my answer is 1. And we could have figured that out without doing that work, because we know anything over itself is always going to give us an answer of 1. Okay, next question. We have our coefficients out front, 15 divided by 5. I know that gives me 3. And then I'm going to do my x's. I have x to the 4th, and this x down here is x to the 1st, so I have 4 minus 1. Then for my y's, I have y to the 2nd and y to the 1st, so that would give me 2 minus 1. and then z is 1 and 1, so I get 1 minus 1. My final answer here, I get 3. 4 minus 1 is 3. Y, I have 2 minus 1, which is just 1. Either write the 1 there or leave it like this. And then z, 1 minus 1 is 0, so that's just times 1. So I don't have to write that in. That is my simplified answer. Okay, for number 7, we're going to review multiplying one more time. So notice there's no division here, just multiplying our two monomials together. So I'm going to start by multiplying my coefficients out front. Negative 6 times 3 gives me a negative 18. Then when I multiply my a's together, I get a to the 8 plus 2. And my b's, I have b to the 3 plus, there's a 1 up there, so plus 1. This makes my final answer negative 18, a to the 10th, b to the